Welcome dear student, this is Wajid and today we are here to explain the topic electric potential energy and potential due to point charge, which is given on page number 31 in class 2nd year book. Before going into the detailed derivation of this topic, let me remind you the previous topics. Electric potential is work done per unit test charge. The unit of electric potential is volt. Electric potential energy. Electric potential energy is the work done. Electric potential energy, denoted by U, is the work done on the system or by the system of charges. The unit of electric potential energy is joule. This topic is very much similar to the topic which we had already discussed in class 9th as the conversion of kinetic energy into electrical and potential and potential energy into electrical energy. Before starting the derivation of this topic, let me remind you that this is source charge and this is a test charge. This is actually the range of source charge, like this. Electric field around the. We are actually going to find electric potential due to point charge. So for calculation of the electric potential, we can take a test charge at a point 1 initially and moving toward this source charge step by step. So 2, 3, 4 and so on. Initial distance is R1 and for next step it is R2. Electric field intensity is already derived in the previous lectures and we can write it like 1/4 epsilon naught capital Q divided by R square unit vector, which is the direction of electric field intensity. In order to calculate electric potential, we need to calculate work done on this test charge by taking it from point 1 up to another point which is inside the field. So W is equal to F into delta R, where F is the force used for doing work, delta R is the change in the position. This is R1, this is R2, so we can write displacement of the charge as delta R, which is equal to R2 minus R1. Or we can write F delta R cos of theta. We can take cos of 180 because the direction is opposite. Direction of the motion, direction of the change to the applied force is opposite. So we can write cos 180 and finally we can write minus F delta R. This is W1. W1 is the work done for this charge to be taken from point 1 to 2. We are now, the total calculation is almost based on this portion, W1. This will be W2. This will be W3, W4 and so on. In order to find the total work done, we will finally add all these to small work done. So we can write minus Q into E, as we know that F is equal to QE, delta R is equal to R2 minus R1 and minus is always there. Next is putting the value of E. We can write minus Q 1/4 epsilon naught Q divided by R square and R2 minus R1. R, we know that minus 1/4 epsilon naught is equal to K, so we will simply write K here minus K small q capital Q and R2 minus R1 divided by R square average. As you note that the distance is variable, so we can take average distance for calculation of W1. Now, what is R average? What is the value of R average? After a simple calculation, we have done it like I can do it here simply, like R average is equal to R1 plus R2 divided by 2 is equal to R1 plus delta R plus R1 divided by 2 R1 plus delta R divided by 2. This is our average value. This is average distance. Now as we can see in the equation, it is R square, so we will take the square of this term, which I have already done to save the time. I will take already the square. R1, R average square is equal to R1 plus delta R divided by 2 whole square. Expanding this equation, we can write it like here. And this term is equal to 0, 2 cancels with each other, and R average R1 square plus R1 into delta R, putting the value of delta R, which is already R2 minus R1, putting this value here and multiplying the concepts of distance, R1 square minus R1 square, finally R1 R2 square. Now putting the value of this R average square in the previous equation, second. Now as you can see, this is equation second. W1 is equal to minus KQ, capital Q, R2 minus R1, R average square. So we have calculated the value of R average square. Now I will put the value of this equation, this R average square, into equation number second. This we can write equation 1, this is equation second. So put the value of R average square into this equation. We have W1 is equal to minus K, Q, capital Q, delta R divided by R1, R2, as I have calculated this value, R1, R2, put it here. Rearranging, simplifying, we can separately write R1, R2 as a denominator to R2 minus R1 like this. Simply cancelling R2, R2 here and R1, R1 here, we have this equation. This is W1. This is actually W1, work W1. W1 is the work done between these 2 points. Similarly, we can repeat the whole process to find W2. So I have written W2. Similarly, W3, W3, Wn, Wn. So we have found the total individual W1, W2, W3, W4, W5 and Wn. Now, as we know that work done is a scalar quantity, so we can add simply all the individual work done, and like we can write minus KQ, capital Q. This is common amongst all the terms, so we can take it as a common outside, and intermediate terms are cancelled, initial and final points are there. We have written this equation. Now we can take it further like this. We know that W is equal to minus K small q capital Q 1 over R1 minus 1 over Rn. I have taken R1 as infinity and Rn is any distance R close to this source charge. Putting these 2 values in above equation, we can write total work done minus K Q capital Q 1 over infinity minus 1 over R. 1 over infinity is always equal to 0, so we can have minus minus multiplied, so K small q capital Q divided by R. Work done. Now in order to find the electric potential, which is the actual topic, electric potential is equal to W divided by small q, test charge. So putting the value of W here, K small q capital Q divided by R. Q cancelled, we have V is equal to K capital Q divided by R. R simply we can write V is equal to K 1 over 4 pi epsilon naught capital Q divided by R. This is equation for electric potential. Thank you. Have a nice day.